Well, that was fun. Get your notes ready. You'll need your notebook, you'll need a pencil, and you'll need your trusty, where is it? Oh, periodic table. Okay, so for today's lesson, we're gonna review ions. And we're mostly gonna focus on ionic compounds. Okay, so if you don't know about ions yet, you need to watch the other video because we're going to get into ionic compounds. And you got to know about how ions work before we think about ionic compounds. Okay, here's a little bit of a warm-up. It's asking, what is the isotope? Oh, it's a warm-up. It's not about ions yet. It's an isotope. What is the isotope name and symbol for an atom with 28 protons and 34 neutrons? As quick review, we know that the number of protons is the atomic number, which is the number in the box in the periodic table, and that was 28 protons. I'm looking for the number 28. There it is. The isotope name and symbol is going to be nickel. So nickel for the name and Ni for the symbol, but am I done? No, I'm not, because the name needs to include a dash with the mass number. And remember, the mass number is the number of protons plus the number of neutrons. You got to memorize that. And that would be 62, unless I did that math wrong. Sorry if I did, but no, I think it's right. Okay, and then the isotope symbol is incomplete. The isotope symbol needs to include the mass number and the number of protons. And this is not an ion, so it doesn't have a charge. Okay, moving on. How many protons and neutrons does calcium-42 have? Okay, well, we know that this number right here represents the mass number, and we can figure out the number of protons just by looking at the periodic table if we can find calcium. So finding calcium, it's number 20. There it is, number 20. So we know that there are 20 protons, and that's how you can answer because that's the symbol for proton. And how do we figure out how many neutrons there are? Well, remember the equation is mass number equals number of protons plus number of neutrons. So if we just plug all these numbers in, 42 equals 20 plus number of neutrons. That's what we don't know. Little algebra lets us know that if we subtract 20 on both sides, that lets us know that there's 22 as the number of protons. Okay, that should be a review. And that's your little symbol for neutrons. Was I saying protons earlier? My fault. I meant to say neutrons. Okay, here's a little review of the modern structure of the atom. Atoms are made of 3 subatomic particles. Protons have the positive charge, 1 positive charge. Neutrons have no charge. Electrons have a negative charge, 1 negative charge each. That's going to be a theme that we need to think about when we talk about ions and ionic compounds is positive charges and negative charges. So we're talking about protons that are positive, electrons are negative. And we looking at the periodic table, we can identify the plus signs as the protons, the red ones without a plus or a minus as the neutrons, and the green ones that are on the outside in the electron cloud as electrons. And what's this central area called? That's called the nucleus. The nucleus. Okay, so as we are learning, we're learning that the number of protons determines the atom's element. The number of neutrons, when they change, determines atom's isotopes. And the number of electrons, when they change, determines the atom's charge. So the only thing that doesn't change is the number of protons with the atom's element. Okay, the number of protons with the atom's element doesn't change. The two things that change are neutrons, making different isotopes. And the other thing that changes is electrons, which can make an atom's charge positive or negative, turning it into an ion. In fact, we should even just write ion right here instead of atom. Okay. Pause if you need to write those notes down, but if you already know that, then don't write them down. Okay, next is atoms with an electrical charge. These are ions. Ions are atoms with an electrical charge. So we don't even want to call them atoms anymore. Let's call them ions from now on. So atoms with an electrical charge. Atoms with an unequal number of protons and electrons. That is what gives an electrical charge, when there's a difference of protons and electrons. We reviewed already that protons have the positive charge, electrons have the negative charge, and you're going to learn some of these names right here. So a cation are atoms with a positive charge. See, they have the word ion in there. So a cation is an atom with a positive charge because it's positive, because cats have paws and it's positive. And an anion are atoms with a negative charge. You can think about it like this: a negative ion, an anions. Okay, so now we're going to learn about how to write the chemical symbols for ions. This should be a little bit of review. So we're asking ourselves, what is the charge on magnesium atom with 10 electrons? Well, if we look at magnesium on the periodic table, there it is, right here, Mg for magnesium. It's number 12, meaning that it has 12 protons. So if there's 12 protons and there's 10 electrons, that must mean that the charge is positive 2. Why? Because we're counting the 10 as a negative number because it's a negative amount of charges, and we're counting the 12 as positive because it's a positive amount of charges. So it's a positive 2 charge. Is it a cation or anion? Well, you just learned from the definition above that this must be a cation because it's positive. And then the ion symbol, you got to write the element symbol. And then where does the charge go? It doesn't go on the top left. It does not go on the bottom left, but it goes on the top right. And that's how you write an ion symbol, just like that. Okay, let's move through these pretty quickly. What is the charge on a fluorine atom with 10 electrons? Looking at your periodic table, you can see that fluorine is right here, but fluorine has 9 protons, but it's asking us what is the charge on a fluorine atom that has 10 electrons. So that's 9 positives plus 10 negatives. That gives us a negative 1 charge. Is it a cation or anion? It's an anion because it's negative. The symbol would be F for fluoride with a negative 1, making it fluoride. Okay. Write the ion symbol for an atom with 26 protons and 23 electrons. So the ion symbol, if we find 26 on the periodic table, it's iron, Fe for iron. And since the protons are winning by 3, the protons are positive, electrons are negative. I know that it's a positive 3 charge. That's the complete symbol. It's a cation because it's positive. That was probably really quick. You could rewind and review if you need to, but I'm expecting you to be pretty quick with these answers as we get into ionic compounds and more. All right, ionic compounds work kind of like magnets. If you've ever played with magnets before, then you got a good head start. So you know that with magnets, there's the 2 sides that will attract each other. And then if you flip one of them around, the 2 sides repel each other. If you ever played with a magnet before, you know that feeling. It's kind of a magical thing. I mean, like, just think about that for a moment. There's a magnetic field that's like keeping you from putting those 2 objects together, and it's invisible, and it's like the force. Okay, so there's a few things that could happen with ionic compounds. We know from playing with magnets that positive and negative will attract. They will attract towards each other, and they want to balance. They'll attract towards each other and they want to balance. So balance, they'll attract and balance. The other thing that we could run into is if there's like symbols, like if there's a positive and a positive ion next to each other, what will they do? Well, they'll repel. That's called repelling. They'll repel away from each other. The other option of what we'll see is if there is an atom with no charge, and then let's say there's a negative ion right here. Well, what will happen is we can call this a no reaction. Okay, we'll call this a no reaction because there's no attracting and there's no repelling. we're going to get into this right here the most. What does it mean when positive and negatives attract and when the charges balance? We're going to go ahead and skip down to this section right here. As a reminder, MCI means most common ion. So at this point, you should know how to find the most common ion for different elements on the periodic table, at least the top 18 or 20. So let's do this example. What is NA's, sodium's, most common ion? Well, looking at the periodic table, you can see that sodium is right here, number 11, and it's going to have a most common ion with a positive 1 charge because sodium will lose its 11th electron to have the same number of electrons like the closest noble gas, number 10, neon. That means sodium having 11 positive protons in the nucleus and 10 electrons in the electron clouds, that's 11 positives and 10 negatives, gives a positive 1 charge. So we would write it like this. And a positive 1. And what is oxygen's most common ion? That's O's, MCI, oxygen's most common ion. Well, that's going to be a -2. Why is it -2? Because its location on the periodic table in relation to the noble gases, which are these elements highlighted. So oxygen has 8 protons. That's the atomic number. But oxygen's most common ion needs to gain 2 more electrons to have the same number of electrons as noble gas, neon, and that's why it has a -2 charge. Okay, so what happens with an ionic compound between sodiums and oxygens? So we have 1 sodium and 1 oxygen here. This is a balance. Do the charges balance? No, they don't balance because this is a positive 1 and this is a -2. So sodium has to call over one of his other sodium friends, and now it's a fair fight. Now there's 2 sodiums that each have a positive 1 charge with 1 oxygen having a -2 charge. Okay, so the compound that forms looks like this. You put an Na, and the number that goes in the bottom corner is little 2. This tells me how many sodium atoms there are in the ionic compound. And then I write O, like this. Okay, now when you put it together, you can tell that the charges attract and they form a compound, and the charges balance. So this is the correct formula for sodium oxide. And that's how you say it, sodium oxide. It's not sodium oxygen, sodium oxide, because the negative ion gets the suffix "ide" at the end. Let's try another one so we can get better at them. Which ionic compound does aluminum and chlorine's MCIs want to form? Most common ions? Well, looking at the periodic table, aluminum is a +3 and chlorine is a -1. Are they balanced? No. Big bad aluminum can beat up on a little chlorine, so chlorine's got to call over not just one of his friends, but 2 more of his friends. Okay, for a total of 3 chlorides. So we write it like this, Al. There's only 1 of them, and you don't have to put a little 1 right here because that you already wrote the Al. You don't have to put a little 1. Then you put Cl, but then you have to put a little 3, and that's the name of the game. That's how you write the ionic formula for aluminium chloride. Okay, aluminum chloride. All right, we're going to skip down to the second example because I'm pretty sure we already did this in the last video. We did this in the last video too, but I just kind of want to drive the point home about different things that could happen with if an ionic compound forms or not. So which ionic compound forms? Well, we got neon and we got beryllium. Well, what's the charge on neon? Neon doesn't have a charge. It's a noble gas. So that's when you can write no reaction. RXN is the shorthand version for reaction. All right, going over question number 1 and 2. Question number 1 says explain what an ion is in your own words. So in my own words, I'll say an ion is a charged particle. And I'll say having protons not equaling the number of electrons. Yep, that's my own words. Number 2, explain the difference between cation and anion. Cation is positive, anion is negative, meaning that the cation has more protons than electrons. Anion has more electrons than protons. Okay. All right, I'm going to do some of these problems in this table, and then you are going to complete the table. Okay. So in this table, we have a bunch of different questions, and we're supposed to be writing the ion symbol, the number of protons, the number of electrons, and answering if it's a cation or anion. We could put just C or A for that. I'll do number 3 for you. I'll do number 7 for you. I'll do number 8 for you. And I'll do number 14 for you. Okay, so here we go. Number 3, we're given the ion symbol. The number of protons, it's hydrogen, so it's 1 proton. The number of electrons, well, if there's a positive 1 for the charge, that must mean it lost its electrons, so there's 0 electrons. Cation or anion, that should be easy because cations are positive, has a little positive sign. Okay, number 7, chloride. The number of protons, I'm going to look at the periodic table. Here it is right here. I'm going to find chlorine. I'm going to say, look, there it is. It's 17 protons. So 17 protons go right here. But the number of electrons must be different because there's a charge. There's a charge of -1. So that means the electrons are winning by 1. Chlorine became chloride by grabbing 1 electron, and now it has 18 electrons total. So 18 electrons. Is it cation or anion? It is an anion. Okay, next is number 14 I'll do for you. So 14 says Ag for silver. There's a +1 charge. The number of protons in silver, if I look at my periodic table and find Ag, there it is. It's number 47. Quick story about silver. Its symbol is Ag because there's lots of silver found in the mountains of Argentina, and it used to be called Argentinium. So it's now called silver. It's probably called Argentinium to some people though. Okay, so there's 47 protons. And since there's a +1 charge, that must mean the protons are beating out the electrons by 1 number, which means that there must be 46 electrons. If that didn't make sense to you, you could always use the formula that we talked about in the last video, which is the number of, which is the charge equals the number of protons, a positive number, plus the number of electrons, which we're calling a negative number. Okay, is it an anion or cation? Very easy, it's a cation because it's positive. Cats have paws. All right, you're gonna go ahead and answer the rest of them in the video. Oh, maybe I should let you pause it or something. There we go. Okay, we're going to skip to number 24. This is where we're really talking about ionic compounds now. This is really where this new lesson starts, is right here. All of that we did was really review, and writing ionic compounds is really where the lesson starts. Okay, so I'm going to go through a few of these really quickly, and then you'll finish the rest of them on your own. So hydrogen and chlorine. Hydrogen has a +1 charge. Chlorine has a -1 charge. They fit together nicely. Just 1 hydrogen, 1 chlorine, and we're going to write the name for all of these. This is going to be called hydrochloric acid. Okay, you don't know about acids yet, but that's just the name of this compound right there. Next one, magnesium and sulfur. Magnesium has a charge of +2. Sulfur also has a charge of, well, it's a -2. That means the charge is balanced, which means you only need 1 atom of magnesium and 1 atom of sulfur. You just write it like this, MgS, and that is, the name of it is called magnesium sulfide, like that, sulfide. Okay, number 26, aluminum chlorine. We already did that one. Let's do potassium and nitrogen. No, we're not going to do that one. Let's do calcium and bromide. No, we're not going to do that one. Oh, yeah, okay, we'll do calcium and bromide. We'll do number 28 for you. So calcium, Ca is a positive 2, where bromide will be a -1 charge. The charges, do they balance? No, they don't. We need to have another bromide in order for these charges to balance. We need to have 2 bromide atoms and 1 calcium atom in this ionic compound in order for the charges to balance and for the atoms to attract each other correctly. So calcium, bromide, and we have to put a little 2 right down there. That's the location where we put the number to show us how many atoms there are inside of the compound. Okay. Okay, magnesium and fluorine, hydrogen and argon. Okay, we're going to change this last one down here to not magnesium and sulfur, but magnesium and nitrogen. And I'll do that one for you right there. Okay. Oops. So magnesium has a charge of +2. You can review that by doing this. Magnesium with 12 protons is going to lose the 12th and 11th electron to have 10 electrons, just like neon, the closest noble gas. With 12 positive charges and 10 negative charges, that's a +2 charge. Nitrogen is located right here. When nitrogen becomes an ion, it wants to have the same amount of electrons as the closest noble gas. So it gains 1, 2, and 3. So it has 7 protons in the nucleus, 7 positive charges, but it gains 3 electrons, which are negative charges. So with 7 positives and 10 negatives, that's a -3 charge. So each nitrogen has a -3 charge. Do the charges balance? Do they balance on a little balance beam? No, they don't. Nitrogen is winning right now. So magnesium's got to call over one of his friends. Well, look what happened here. Now the magnesiums are winning. Nitrogen's got to call over one of his friends. Oh, look what happened here. Nitrogens are winning. Magnesium's got to call over one of his friends. And now it's a fair fight with 3 magnesiums and 2 nitrogens. So the formula looks like this, Mg3 and 2. And that's how you do ionic compounds. Please do the rest of them on your own for practice. You need to get good at this and quick at this. Good luck.